And welcome back. Thanks a lot once again to all those of you who made it at the online gathering, the Java Day. Hi, Rafael. A real pleasure to have you with us.
Hello, thanks for having me.
Sure. I'm not Neo, but when I hear about agents, I get, I don't know, anxious and cautious in a way. How are you today?
Yeah, I'm fine, thank you. Yeah, agents, pretty overloaded term, not only in the programming space.
Exactly. Just for my curiosity, any resemblance between these agents and the Java agents? In a way,
Yeah,
they merge somehow.
I think the secrecy aspect is certainly a name giver, but other than that, it's pretty harmless day-to-day machinery.
Okay. Where are you based, Rafael?
I'm based in Oslo. I'm originally German, but I've lived here for soon 8 years and feel pretty Norwegian these days.
Okay, so feeling at home, right, in Oslo now?
Yeah, it's getting colder now, fortunately. It's been quite warm. Now we're back to the normal.
Excellent. Okay, once again, welcome. Thank you very much for joining us today. Well, let's see about, well, the story about the agent.
Yeah, sure, let me share my screen. And can you see it?
Yes.
Brilliant. So yeah, I'm trying to do a definitive guide to Java agents. Given the time, it's probably going to be less definitive than normally. But the goal of this presentation is to at least teach you the basics, what a Java agent is, because I'm sure a lot of you use them even on a day-to-day basis. They've become pretty common in the Java space. And in this course, I'd like to show you how they are built and give you like a teaser to how agents work and how you can implement them yourself and how to find out more about them once you understood how they generally assembled. So the first basic question obviously is, what is a Java agent and how do they look like? So we're going to do some agent fundamentals. We look a bit deeper into code instrumentation. How can you do code instrumentation from Java agents, which is what they normally used for. We'll have a short look into class loading, which is fairly important to understand, not only for agents, but in general in the Java space, but for agents, class loading is very essential, a mechanism you need to have a relationship to. And then if you have time, we'll look into a few other things regarding agents, which are nice to know for agent development and in general. So what's a Java agent, right? First question we should answer before we dive into anything. And you all know that a Java application is started by invoking its public static void main method, right? This is where you start running a Java program. And a Java agent, in essence, is nothing but an alternative entry point to a Java program. So a Java agent is a Java program in itself, but instead of having a public static void main agent method, the agent has a public static void pre-main method. And in the manifest, instead of referring to the main class, you refer to the pre-main class. And other than that, there's nothing to it. So if you specify an agent on the command line, and you can do so by just setting -Java agent and then pointing to a jar file, you can execute a program in the same Java virtual machine process as you are executing your main program in. And there's no limit to it. You can have several agents in a program, and as the name suggests, a pre-main agent will be executed before the main method to allow you bootstrapping a Java process in the way you want. You can, for example, set properties that you don't want to be set and so forth. But you can also do other useful things that we'll quickly look into in just a short while. That's not the only additional entry point Java agents provide, however. There's not only pre-main, there's also agent main. And agent main mainly means it's still a Java agent, but it's not running in the main thread, but it's running in the agent, in the attachment thread. And it's running in parallel to the actual program. And by registering an agent main Java agent, which you specify in the manifest again now with agent class instead of pre-main class, you can basically do something in parallel to the same program that you're running, but this time you're not blocking the execution, you're just doing something in addition. And the nice thing about agent main agents is that you can execute them and attach them to a Java process even after the JVM has already begun running. So you can find any running JVM process and basically inject an additional program into an already running execution. And again, you can have multiple such agents, but they can all run on the attachment thread and subsequently. But of course, once you terminate the agent main method, you can run the next agent, and any agent can start new threads and run its execution logic there. So how does a so-called static pre-main agent look like? Basically, as I said, it's just a pre-main method, public static void. It doesn't have an argument of methods, an array of arguments. It has a single argument, which you specify as you see here on the command line. So you run Java class path something, and then you say, as I mentioned before, Java agent, and then the location of the jar file, and then an equal sign, and that what comes after is the optional argument. If you skip the equal sign, arg will just be null. And this will just print hello world from the agent and then execute the normal application. And of course, it isn't a very meaningful program this here, but it gives you the impression of what it is. That's a Java agent, and you can, of course, modify the global environment, set system properties, or load classes, or whatever you want to do, and it will affect the subsequently running program in the way you hopefully intended it to. A dynamic agent, or agent main method, it's the same thing, but this time you just start up your application as you normally would, and then there's an API in the JVM for this, with the virtual machine API for attachment, where you can just specify the process ID, the PID, and then you attach to this virtual machine, and you can load any agent you want to. You specify the path again, and the argument is its own argument, and then you have to detach again. So you basically connect to a JVM, then you load the agent you want to load, and then it will be executed in this very same process of the PID, and then you disconnect again. But the agent that you dispatched will continue running even after the detachment. And this way you can modify programs while they're running. And why would you do any of that? I mean, of course, there's the possibility to log something, to set properties, but most agents, yeah, by the way, this is not insecure, I should mention that. Some people might find this scary that you can attach to any Java process from another place. You can only do that if you are running as the very same user as your JVM process. And once you have the privileges of the user running a process, you own the process already. So it's not a threat to your security model or to anything. So it's a fairly nice and safe feature. And yeah, so you can just move over, right? So why would you do any of that? Agent, both the static one and the dynamic one, they can specify a second argument in addition to the argument that you can put on the command line. You can ask for an instance of instrumentation, and instrumentation gives you access to some low-level functionality. And the most popular one, and this is why everybody is writing agents, a lot of tooling vendors are writing agents, is that you can register a transformer. And a transformer means that any class that the JVM loads, any class, be it a system class or an application class, a class from a library, will be put through this transformer, giving the Java agent the possibility to modify a Java class before it is loaded. So let's say you're using Apache HTTP client in your application, then if you register a transformer, the transformer will be asked, how do you want this HTTP client to look like? And the easiest case, it just returns null, meaning that there won't be any modification. But if it does want to apply a modification, the Java agent can do so by basically taking the class file, which is just a byte array, and returning an alternative byte array that is the new class. And as you can think of, this can help you to modify things. You can, for example, add logging to every method call of a certain class, or you can add tracing, you can add security checks, all these cross functionalities that you would normally have to hard code in your app, a Java agent can just patch into. And this doesn't only work from a pre-main agent before a class gets loaded, it even works from an agent main class after a class gets loaded. So the agent main just says retransform classes and tells the JVM what classes it wants to change. And then it also tells the transformer that it wants to be eligible for retransformations. And then the agent can change classes even after they're loaded. So technically, a dynamic agent can go into a running JVM process half a year after it's been started originally. It's been running for half a year and nothing has changed. It can then hook into the JVM process and just hot patch a class. It can, for example, update a field value to reflect a new date if that's the only thing that needs to be changed. and without halting the process. So the process will always be available. And then, of course, it can do the same things that the pre-mem agent can do that we mentioned before by adding logging and so forth. And that's a fairly powerful concept, of course. The only downside here is that the class file that you presented is a byte array, and you have to return a byte array, and you have to do transformation manually there. And fortunately, there's tools for that help you transform classes and class files. And one is that I write. This is also why I'm doing this presentation. It's called Byte Buddy. It's a helper tool for class file transformation, but I'll try to speak about Java agents more in general here to show you basically what this can be used for and how you can apply these changes. So when you transform a class that is already loaded, there's some limitations, however. You cannot, you can change the return value of a method. So you have a method that returns foo, you can make it return bar. Like I said, like change a date that's hard-coded somewhere that you have to change without having the opportunity to kill the process. What you cannot do is you cannot add methods unless they're private, but this was recently taken away too. So you cannot change the structure of a class file. You cannot add fields, and you cannot change modifiers of methods or of classes. However, there's an extension, Java enhancement proposal 159 for the so-called dynamic code evolution VM. So this limitation might be lifted at some point in the future. However, at the moment it still exists, so we can't go there, and basically we're having it backwards these days. Before Java 9, you could add private static methods, but this is also gone now in the recent releases. Just to have mentioned it, there's a third form of agent in the JVM, not a Java agent, but a so-called native agent. So instead of specifying a Java agent, you can also specify agent lib and provide an SCO file, and then you can run an agent written in C. And this is how it looks like. I won't go into this because, as you can tell, it's more messy than Java application like C tends to be. Basically, it tells you, yeah, I want to retransform classes from the agents. I have to add capabilities to some array, and then I can install a hook. And these hooks are typically written in Java anyway, so there's no big point for these general agents, but there's some reasons why you might want to use a native agent, but typically you don't. But the opportunity exists, certainly. So if you want to look into this and if you're more comfortable with C, then this might be an option too. So now you know that this exists, so we can look more into Java agents again. All right, so how does this work? How can classes be manipulated at runtime? So you just write a class foo with some methods and some fields. And this class foo is then compiled by Javac in a class file. And this class file is already fairly structural. So it's fairly easily machine processable because everything that's white spaces, that's formatting, is stripped, and we just have the instructions. And it's binary, and the binary class file is just a byte array. And like any class file, you've probably heard of that. They start with the Cafe Babe magic bytes in the beginning. And then from there on, it's all written down in Java specification what any byte means in this class file. So all you need to know is you need to know what byte means what, and then you have to switch these bytes out to mean something else. So you have to add new bytes to add meaning, but you have to do it in the right place and in the right format. Otherwise, the JVM will reject the class file and fail with a so-called verification error. You might have seen these too. So, and of course, you don't want to do this manually. You could read the specification and see what byte means what. But what you more likely will be doing is that you use a tool like ASM or Byte Buddy. And this is what we're going to look into for the rest of this lecture. But before we do that, just a tease of what you can accomplish with that. And you probably have used Java agents before because tools like Mockito, where I'm also a maintainer of, and we use Java agents in Mockito. So why would we do that? Because the JVM runs Mockito, right? But we can attach ourselves to a JVM and become a Java agent. The library can just find out what the PID is of the current process and then hook into it to get the instrumentation API. And then even a library can use the instrumentation API. It's a bit hacky, but it's very useful because what Mockito does is, if you've ever used the so-called inline mock maker, is that instead of subclassing types to create a mock, which is the normal approach to mock making, we can also redefine classes and inline the modding logic into methods, right? So instead of executing bar, we can have like an if this is a mock instance, we do the mocking stuff, else we do the normal stuff. And this way we can mock final classes and final methods. Before with the subclass approach, we couldn't do that. And then languages like Kotlin came along who wanted to, or who do effectively declare most classes final and most methods final, and it doesn't work. So using Java agents, we overcame this limitation, and today we can even mock static methods, which is basically the same thing. We can mock constructors because we can inline code using instrumentation. Or what might be the more common approach to using Java agents, if you ever used the application performance monitoring tool, like I've been working with one called Instana, what we do there also is that we find Java processes by scanning the JVM for PIDs, and then we just attach to these JVMs and instrument the JVM to, for example, tell the agent that some HTTP call is made and add some context headers when the call is leaving the JVM. And this way we can then suddenly track interactions between different JVM processes, because we can inject the headers in one JVM and then extract the headers in the next one, right? And even cooler, we can just redo the process. Once we update the tracing tool, we can just remove the agent version 1 and re-instrument with the new version of the agent, so you never have to restart JVMs. So then you provide feedback from the JVM, and based on this feedback, you find, for example, right, this JVM needs some instrumentation for this and that library, but it doesn't exist today, so some developer just adds it, deploys a new agent, the agent updates the JVM without even restarting. So the possibilities are fairly broad with Java agents, and it's definitely a nice tool to have in your toolbox. Right, you can even intrude containers and so forth. There's no limitation to how ambitious you want to get. Right, so that's Java agents, right? Next step is to learn how to implement them. And that's, of course, the more daunting part of Java agent implementations. And the most universal approach to class file transformation is the ASM library. ASM doesn't have anything to do with CASM. It's just borrowing the acronym. But basically what ASM is a visitation library. And everything starts in a class reader, which takes a class file that we've already seen that you get that provided from the Transformer API. And then it has that's the source, and then we have a sink, which is the writer. And the easiest ASM usage is to just have a reader and a writer, and then you just accept the writer from the reader, which means that all bytecode instructions, all class file information is replayed one by one to the writer, and then the writer will in the end contain the same class file. That's again not very useful, but you can of course intercept this visitation by adding visitors to this visitation chain. So instead of accepting the writer directly, you can add a class visitor, add the writer as the parent. What you can see here is the second argument of the constructor. And then, for example, we can override the visit method. And the visit method is just called once for every class, where it gives you information about the basic properties of the class. For example, the Java version of the class, the modifiers, here called access of the class, the name of the class, the generic signature, the superclass name, and any interfaces implemented by it. And by invoking the super visit method, so basically calling the same method downwards, we can replay the same instruction to the writer, but in order to change something, we now don't just supply the access value, but we add the public modifier to the access value, meaning that now the class's visibility will always be public, because we take any modifiers on the class, be it final, be it static or whatsoever, and then we add public. And that way the class will have become public. The writer to byte array will now return the same class file as the original class file, only that we have made it public. And from a Java agent, you could do that. You could make this is basically all that's needed to make any class in the JVM public. Is that much code, and that's fairly convenient, right? This is not so hard to do once you know how to do it. But of course, this API can quickly explode into verbosity. and I'm not trying to daunt it here to say like this is not nothing so you should use. Byte Buddy itself uses ASM under the covers, but if you add more and more logic, for example here logic to change a method, now we want to override the visit method, and then we call the super method, then we return a new method visitor where we wrap the original method visitor, and then we want to add code here where we add a system out println to any method that's found. And this is still fairly easy, but you can imagine, I don't even want to go into details here, that the details of writing big ASM applications typically puts some challenges on any team, because you have to write bytecode, and then you can easily make mistakes, switch out some lines here, and then you will break your class file, right? So it's not very safe and convenient way to write Java bytecode, but it's a very powerful way. So if you want to do very powerful things like implementing a bytecode generation library like I did, then you certainly want to use ASM. So this is how it looks in Byte Buddy on the other side. Byte Buddy has a more descriptive, declarative approach. And this is the agent builder API. Byte Buddy's normal entry point is the Byte Buddy class, and then you can, for example, generate classes therefrom. But with the agent builder API, you can first create an agent builder here. Then you specify what types you want to match. And basically Byte Buddy provides you something that's similar to the reflection API. So type accepts an element matcher, which is a functional interface in Java. It's functional because it only has small methods. Byte Buddy is written in Java 5, so you can still use old Java versions. And then it has a descriptive matcher DSL, but you can just implement your own matches if you want to. And here we say, like, we want to match any type that has a super type that's named my target user type, right? So without even having to load a class or to know a class or have a reference of the class, you can just say any class that inherits in some way from my target user type, we want to transform. And then we say in the builder, we want to intercept any method that is declared by these classes. And then we want to add this method call invoke println with hello world on it, right? So we print hello world from any method, and then we invoke the super method. The super method being the method that the original implementation. So now that we applied this Java agent, and this is an actual running agent, you can copy paste this code and execute it. This will make any method of your given class print hello world before doing the actual implementation. Again, not very useful, but it's just to give you the idea of what can be done. Typically, you would do some assertion, you would do some logging, something like that, and be more precise about what you want to intercept, but it's a nice demo. All right, so how does Byte Buddy do that? Basically, it takes the user type, it copies the original method into something that's called like foo original, which is typically private or something. And then it defines a new method foo, where it prints out hello world and then invokes the original method as shown. The super method, so-called, is now foo original. If the super method is not actually defined on user type, it will do it like with toString. It will again print hello world, but instead of calling the copied method, it will invoke the method of the super type. Byte Buddy calls this rebasing a class. So basically subclassing a class, but within the class. But as you've learned, this doesn't work for agent main agents, which are the more interesting ones. It only works for pre-main agent because we cannot define new methods in a class. And this is why this wouldn't work. But fortunately, there's utilities for that, but now you know that this exists too, right? The more common way of writing Java agents in Byte Buddy is using the so-called advice class. And this time, instead of intercepting a method, you use the so-called visitation API. And this is a lot for, if this is the first time you hear of the library, it's a lot of terms to get into, but it's more trial and error. Visitation API means you decorate existing methods with so-called advice classes instead of overriding them. So using advice, you cannot replace the original code, but you can add something at the beginning of every method, and you can add something at the end of every method without changing the method otherwise. So for example, if you have a method annotated with onMethodEnter, which is your advice class, and you say advice to hello world advice on any method again, of subclasses of my target user type, then now again we will print hello world on every method. This time we will, however, only affect declared methods of every type. What Byte Buddy does, it takes the foo method and just copy pastes this template, this advice template over. It is important to understand that it copies the code. It doesn't delegate or anything, because if you set a breakpoint in your advice class and executed the program, it wouldn't trigger the breakpoint because your code was actually moved to the new location. But this is how a lot of big vendors write their Java agents today. Mentioned Instana, but many others, from Datadog to other big companies, they use this approach to easily add code, and it basically allows you to just write Java code and still write Java agent, which is nice because you can still test your code, for example, but just invoking on enter in your unit tests and have the library take care of all the gory details, right? And this is again just printing hello world, but imagine you can now, for example, do something like measure the timing of the method by having on method enter, and as you might guess, there's also on method exit, so you can do something as well at the end. And now just by adding with redefinition strategy retransform, you can even transform existing classes, because now we don't change classes anymore, so we can actually apply this, and this agent will now pick up every class loaded or not loaded. And again, don't trust me for it, just take the code and execute it, and you can now retransform any existing class in your Java application to print hello world in the beginning. Additionally, you want to put disable class format changes there to do some optimization, because if Byte Buddy knows that classes will never change their format, so it will never add fields or methods, it can do some optimizations to run faster. Right, so it's always good to have that, though it's not technically required. Yes, and as I mentioned, instead of only having on method enter, you can also have on method exit, and if you execute this twice, Byte Buddy will copy the enter code there. It will then copy the return value, basically run the original method, but instead of returning immediately, it will just store the result somewhere, and then also copy the exit code in there and then return. So you can do both, and this looks easy, but it's actually quite complex. So if a method has several return places, then Byte Buddy uses goto instructions internally to rewrite the bytecode, and you can of course do all that with ASM, but Byte Buddy is just an easier way of accomplishing it, at least in my opinion. And yeah, so you can just do whatever, and the method can look however it wants, and it will still work. Yes, so you can also, of course, read arguments by having annotated parameters in your advice class, and you can even change arguments from your advice class. So this will render this bytecode in your users class. So for example, and this is an actual application of Byte Buddy, there's agents that do security assertions. So if you have like JDBC API and you get arguments to JDBC which look like SQL injection, then a Java agent like Screen will use Byte Buddy to remove this SQL injection and trigger a warning instead. Right, so all this is possible. You can also change return values if there's similar problems. And as a fourth, there's a whole lot of possibilities that you can do. And there's other talks I've given where I go into details of all of these annotations. This is just a selection, but the best way of learning is just to trial and error. There's plenty of unit tests you can look into, for example, in Byte Buddy, and I wrote blog posts and so forth. So just that you know, all these exists and more, and you can basically do anything with Byte Buddy that you could do in Java code. Yes. As I mentioned before, advice are only templates, so there's limitations. For example, you cannot access fields of the advice class. The fields don't exist, right? It's template. We copy the code. You cannot call private methods either, for example, because the private method is private. And if you copy the code of the advice class, then this private method will move location and not be able to trigger the private method anymore in its new home. So instead of that, you have to inject values using your own constants. You can define bindings. So you use your own annotation and then say, like, whenever I encounter an argument of this annotation type, then inject this value. This will work. Fields and methods won't work. So it's a templating language like AspectJ or others, just written in Java, in regular Java, not in its own language. Yep. All right. So I've used half an hour, which is the normal time it takes me to get here, but we have less time, so I'll just look into a few concepts in the reminder before we go into questions, if you have any. But this is the general approach. You identify methods by just matching them by known properties using reflection-like API, and then you specify how you want to change them, hopefully also in regular Java code using advice. Or if you do a pre-main agent, you can do the regular matching too, which is used in the thorough, in the reminder of Byte Buddy everywhere, but it's not about retransformation, but yeah, advice is typically a good way to go. Yes, and it sounds very easy on the surface. Byte Buddy is a huge library to cover any case possible. And a lot of this code is addressing class loading and the difficulties of dealing with class loaders. Because if you look into a JVM, it starts out with 3 class loaders. You have the boot class loader, you have the extension class loader in Java 8 and earlier, and you have the system class loader. The boot class loader loads any Java class, Java lang string, Java lang object, and so forth. That's part of the standard library. The extension class loader isn't used basically in Java 8 and before. You can put jars in your JVM installation and they will be put on the extension loader. So it's like an old Java EE thing. They have that. And then you have the system class loader, which represents the class path. So all your libraries and all your code that you added. And in Java 9, the extension class loader was removed, and instead we got the platform class loader. The platform class loader now loads libraries of the JVM that shouldn't have root privileges. Classes loaded in the boot class loader can do any kind of things with reflection. So for example, the Java SQL module is now loaded in the platform class loader to take away these privileges, because that way it's better isolated. And if there was a vulnerability in the SQL library, it wouldn't mean that it can just escalate the privilege to everywhere. So now only essential libraries are on boot, additional libraries are on platform, and your stuff is still on the system class loader. And then you have modules within each class loader. And it could be so easy, however, if you run a Tomcat server, this Tomcat server will generate a new class loader, one for each web app, for example. And if you use OSGI, there will be OSGI class loader hierarchies, and then someone can do a custom class loader. Has a whole world of pain within class loading. It's a very powerful concept, but if you have to explicitly work with it, you can tell that it can be difficult. A Java agent is always loaded on the system class loader. No matter what you do, it will end up there. And that means that if you write code in your agent, it won't be able to see code of your Tomcat deployment, for example, or of your OSGI deployment, or any custom logic, because class loader hierarchies only go upwards. So the system class loader can see the platform class loader, can see the boot class loader, but you cannot navigate from a parent to the class loader children. Actually, you don't know the children, you cannot reach them. So that will cause this advice to break, because HTTP request, for example, might only exist in Tomcat, and you're on the system class loader, not on Tomcat's web app class loader. If you have a tracing tool, it will possibly not be visible because it's on your system class loader, but the custom class loader that we've seen here that can't see the system class loader. So there's a whole range of visibility issues. But fortunately, you don't have to care about any of that when using Byte Buddy, because Byte Buddy creates, if you don't use advice to a loaded class, you can instead use a so-called agent builder transformer for advice, include any class loader you want to make sure is visible during the advice application, and then Byte Buddy will make sure that the transformed class is also visible. So now you just say advice for any method named send of my HTTP client advice, and Byte Buddy will render a pseudo class loader description, a so-called type pool, which includes any class loader that's involved in a specific transformation, and then load a pseudo class description from there. And that way you can just write normal code, you can just write normal advice, and at runtime, Byte Buddy makes sure that everything is put together in the right way and everything's visible. So basically what I'm trying to tell you by talking about class loaders is that while it's important to understand them, hopefully libraries protect you from considering class loaders within every application of a Java agent that you will ever write. Yes, I have 10 minutes left, so I'll do like 3, 4, 5 more minutes to some additional information, and then we have at least 5 minutes for questions. So let me just, yeah, this is maybe interesting to see. So one thing you can do with Java agents is you can make them uploadable, updatable. And an important thing to understand about class loaders is that these 3 base class loaders I've shown you before, the bootloader, the extension or platform loader, and the system loader, they are permanent. All these class loaders will exist for any JVM's lifetime. Every other class loader can be garbage collected if the class loader itself gets eligible for garbage collection, so it's not referenced by anybody anymore, which means that all classes loaded by the class loader also need to be eligible by for garbage collection. So a class points to its class loader, and a class loader points to all of its classes, and so all references need to disappear. So if you want to write an updatable Java agent, you have to make sure that all your classes are eligible. So what you typically do is you keep your class loader referenced in a static field, and the next time you trigger your agent, you can just provide a new argument. This class, since it's the Java agent, will always be sticky on the system class loader. So the field will be the same the next time you attach the same agent. But if you provide a new argument, then you can just remove the old class loader and there with the old agent and start a new one. And that way you can basically make your agent updatable, and that's what a lot of libraries or ready-made agents that you can purchase from APM vendors, for example, do these days. They make sure that you don't have to restart your JVM. Instead of they make the agent eligible for garbage collection and attach a new one. This is basically the mechanism behind it. Yep. So now I'll jump over a few slides. Yeah, self-attachment is interesting, but we'll skip over it. So basically, if you want to attach to your same JVM as Mockito does, the easiest way to do so is use a side project of Byte Buddy, which is called Byte Buddy Agent. And all you need to do is to do bytebuddyagent.install, and you'll get an instrumentation instance. That's not only useful for libraries like Mockito, it's also useful for trying Java agents, because that way you can just try things within your JVM process. So like in a unit test, you can still apply an instrumentation by installing an agent and then just registering a class file transformer and retransforming a class, for example. So you can write a public static void main method and then do an installation and then try instrumenting a class within your class path. That's the easiest way to get started. And you can also use Byte Buddy Agent to attach to foreign processes if you want to, so you don't have to re-implement all kinds of things. Byte Buddy can even emulate the attachment API, because attachment until Java 9 was only possible on JDKs. Since Java 9, there's no distinction anymore between JRE and JDK. All you need is to have the JDK attach module available, which normally is available now. But before Java 8 and in Java 8, it's easier to use a library like that. Yep, this one we skip as well. One last thing before I'm finished with my presentation. When you write Java agents, and basically whenever you share a JVM process, you need to consider that your Java agent is a process besides the normal process, but it shares the process and the JVM infrastructure. So let's say you have an application where some objects are short-lived and some objects are long-lived. Then the normal program would, for example, identify some of these objects as young generation and some of tenured generation. The concept of generational garbage collection. So once the young generation objects become eligible, they're collected, and that's much faster than collecting the tenured generation, which is typically a more expensive operation. So the garbage collection performance of this program might be just fine, but once you add a Java agent to your application, and the Java agent has many more short-lived objects than the original program, then these objects will change the definition of the JVM's tenured and young generations lifetimes. So suddenly your program, the original program, might be much slower than it would have been. And that's not exclusive to Java agents. A library that collects a lot of small short-lived objects in a short time can also change the behavior of the remainder of the application if it runs from a different thread, for example. but it can be that you as a user of a Java agent suddenly observe a way different garbage collection behavior once the agent is active, and that's why. So if you write agents, be sure to be resource conscious. Otherwise, you can break a lot of code very quickly, and not by breaking it in terms of functionality, but in terms of performance. And yeah, this is something to look out for. And that's it from me. Perfect. 5 more minutes. My time's up. I think I haven't even mentioned, my name is Rafael. I do a lot of open source in the Java space, and you can find me on Twitter and on my webpage if you're interested in Byte Buddy, Mockito, these low-level APIs. I also maintain a library for document conversion called Documents4J, which allows you to, for example, use MS Word from a Java process, which you now also know exists, and you can find all that on the internet. And you can find me on the internet if you have any more questions. I know it's a lot to get into, but I hope you got a good overview. This is not intended to make you an expert, obviously. It's intended to give you a good teaser to get you started learning. And I'm happy enough to help you out if you have more questions, so just reach out. And I have maybe time for 1 or 2 more questions if there's.
Yeah, thank you, Rafael. Very well done. Very, very good walkthrough and very good overview. I'm cured now. I'm not afraid anymore of agents.
That's good. That's if I
can live in.
I'm happy.
Yeah. Right. Okay. The first question would be, how do they relate with the aspect-oriented programming, the AOP concept?
Yeah, so agents are in a way, or the way Byte Buddy implements agents is a way of aspect-oriented programming because it's declarative. So you say, I wanna change classes that match a certain criteria, but Byte Buddy isn't limited to aspect-oriented programming because you don't have to write some join point expression language. You can programmatically decide what you want to intercept. And I think this is a good way to get started at least. And you can set breakpoints and you can look into the single steps of everything that happens. So, but of course, ideally you end up with something purely declarative. I want to change all classes annotated with XY. That's a good agent. You don't want to do it erratically. And but you do it however you want to do, and then aspect-oriented programming is a subset of agent development. Okay, I think that clarifies the question. Then thinking of, I don't know, a couple of things, like benefits where agents are obviously the solution. So the big advantage of agents is that you don't have to, so thanks to the declarative concept, right? So if you have a performance tracing tool, you want to for example, trace every HTTP exit of a program and every HTTP entry. If you do this manually, like programmatically, and this is the big downside of programmatic solutions, is you can miss things. You have full flexibility, but the flexibility implies the opportunity to miss an exit or an entry because it's so flexible. It's free. And if you have a tool that fully relies on not missing anything, and tracing is one of these applications, right? Then agents and the aspect-oriented approach to it allows you to make sure you don't miss anything. Let's say you have a security library and you don't want to miss a single SQL injection, obviously, because one is too much. Then you can lay over the JDBC API declaratively, and by laying it over it declaratively, you let the machine do the decisions. And the machine isn't wrong if you give it the right instructions, and by breaking down the instruction to something digestible for a human, you can, in a way, make sure you don't miss anything or less likely miss anything. So this is the main upside of using an agent, I'd say. So you have a cross-cutting concern. You want this to be taken care of without thinking of it yourself. That's the major.
Yeah, right. And I guess it's also related to the moment when you can apply it, actually.
Yeah, exactly. So
imperative.
You can write a unit test without thinking about it, without caring about it. And that's, of course, That's where annotation-based computing is also an advantage, right? You write a method, you annotate it with some contextual logic, and then you can separate concerns. So agents help you to separate concerns. But of course, it's a balance. If you do like too much magic, like people like to call it, and then it gets less intuitive. But if you do the right amount of magic, it can get much more intuitive. I mean, we live in a world of abstractions already, right? The JVM is just a metaphor for how a program is supposed to work. It's not really executed the program itself. It just describes how the program is supposed to work. And it works, and we don't think about it. And we don't think about garbage collection, all these things that makes us productive. And then that's what agents are also as well. It's a production improvement tool just for the developer, not for the machine.
Right. Have you seen any, I don't know, any situations when agents were like abused, like misused? Any popular or usual suspects?
I wouldn't point out anybody here, but yeah, of course, agents get abused all the time, like anything in programming, really. You have a problem, you have a hammer in your hand, so use the hammer. No, I mean, you shouldn't use, if you write an application, you shouldn't use agents for crucial domain logic implications. You should only use agents for technicalities and optional things, right? Things you can take out without changing the semantics of the program. Agents are about changing structure, not about changing semantics. That's kind of maybe important to keep in mind.
I think you nailed it very.
Thank you.
Okay, Rafael, it's been a real pleasure.
Thank you. It's my pleasure.
Like a very short break till 7 o'clock Eastern European time. We're really hoping that we will have the chance to meet in person soon, of course.
Yeah, I'd love to.
Until then, maybe
in 5 years. Let's hope earlier.
Right. Okay. Thanks again.
Have a good night.
Until next time.